Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corin. So as you know, I was spending quite a bit of time last week on those really frustrating small little things needed to get our home server and computers back working. We're talking CPU coolers with those fan clips that are always just a pain in the backside to get in, but without which the CPU won't be cooled, you'll get thermal throttling, and suddenly everything won't work. And the world of computer repairs is kind of frustrating. It's very small, but if you don't have the budget to pay a computer lab to repair or upgrade every little thing for you, it can be not only a thrifty solution, but the most viable way to get something done. And it's empowering, as we talked about before. So when I was peering into my computer and looking for installing the CPU, AI is just such a transformative tool in this regard that it's hard to overstate its importance. There's just things I wouldn't have even attempted a few years ago when all we had to rely upon were YouTube videos and Reddit forums, that now it feels I'm much more I feel like I can take almost any repair project on so long as I have my trusty buddy ChatGPT on hand. Now the method I'm using is where I see there could be predict with AI there's going to be a lot of potential for efficiency gains. I have an excellent camera, which has been the second transformative aspect. It's just a OnePlus phone, but it has an almost freakishly good zoom lens, and I can really zoom in and take very detailed shots. We're talking about literally being able to see individual pins on pinout slots that I can't even see with my eyes, but I can take a really high resolution shot and send that straight to ChatGPT and say, hey, which of these two pins do I want to put the power into? So that's been an absolutely brilliant process, and honestly, without it, there's simply no way I would have been able to figure this stuff out. But that's kind of a very slow solution, and maybe that's why it's one way to learn the ropes, but it's probably why my CPU cooler installation took me hours, and that's not really sustainable. So I kept thinking there's two potential things that would be brilliant. If I were to devise the optimal tool for this job using AI, I would say, well, probably live would make a huge difference instead of constantly relaying photos back and forth and ChatGPT saying, no, it's this pin, not that pin, if it was a live feed. The second thing that would be brilliant would be something like annotations or AR. Now, what happens with ChatGPT is you can send in annotated shots, photographs, but the AI can't annotate back. So it resorts to these kind of cumbersome descriptions like the fifth pin on the second row, whereas if it were just able to literally draw an arrow and saying, put it here, that would be vastly easier, especially when you're hunched over a computer case and working on these tiny parts. Now, I know that there's been a lot of interest in AR, and I think this is one of the most ideal applications. And you could extend this to repairing just about anything else that's kind of complex. Think about cars, right? You've popped open the bonnet, or the hood as Americans call it, and you're looking for something under the bonnet. And if you could have, whether it's smart glasses or just some other method, that you could say, hey ChatGPT, I have a Seat Ibiza 2012, I've popped the hood, I'm looking for the washer, the wiper fluid reservoir, for some reason I can't find it. And it would say, well, based upon the configuration which I have in my knowledge, check here, annotates on your screen. So you get the concept. It would be brilliant. Herman and Corin, does this tech already exist? If so, what is it called? And what is this area called where you're having, let's say, a fusion of, because you need both aspects, you need AR for the visual overlays and you need AI for the intelligence, knowledge, and real-time chat. I'd be very interested to learn about the confluence of these two technologies in this use case, in today's episode of My Weird Prompts.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am joined as always by my brother, the man who probably knows more about the internal circuitry of a 1984 Macintosh than anyone else in Jerusalem. How are the capacitors holding up today, Herman?
Herman Poppleberry here. And Corn, for the record, it is not just the 84 Mac. I have a very healthy respect for the Apple IIgs as well. I spent my morning recapping a logic board from 1986, and let me tell you, the smell of old solder is better than coffee. But today we are looking at something a lot more modern. We are jumping from 40-year-old hardware to stuff that feels like it was ripped out of a science fiction novel from 2030.
Right. So, today's prompt comes from Daniel, a long-time listener who had a very specific, very visceral frustration last week. He was trying to repair his home server, specifically wrestling with those tiny little fan clips on a central processing unit cooler. If you have ever done it, you know it is basically a rite of passage for computer builders. It is cramped, the fins on the heatsink are razor sharp, and you can barely see what you are doing because your own hand is blocking the light.
It is the ultimate test of patience and fine motor skills. It is the kind of job where you end up with 3 band-aids on your fingers and a deep resentment for industrial design. And Daniel was doing what most of us do now in 2026, which is propping up a smartphone, using the camera to zoom in on those tiny pins, and then trying to describe what he sees to a large language model to get help. But as he pointed out in his email, that is a very slow, 2-dimensional way to solve a 3-dimensional problem. He is looking at a screen, then looking at the motherboard, then back at the screen. He is losing his spatial orientation every time he blinks.
Exactly. He wants to know if the technology already exists to combine artificial intelligence and augmented reality for these kinds of complex repairs. He is dreaming of a world where you get those real-time visual overlays, like a video game objective marker and intelligent guidance that actually knows where your hands are. What is this field even called? And how are these two worlds actually merging right now? Because it feels like we have the ingredients, but the cake isn't fully baked for the average person yet.
It is a fantastic question because we are right in the middle of a massive shift in how we interact with physical objects. If you want a name for the field, most people in the industry call it spatial computing or augmented maintenance. Some of the more industrial-focused companies refer to it as intelligent field service or even prescriptive maintenance. It is the evolution of the technical manual. We went from paper books to PDFs on a tablet, and now we are moving into the era of the living manual.
Prescriptive. That is a step beyond predictive, right? We have talked about predictive maintenance on the show before, the idea that a sensor tells you a bearing is getting too hot and will fail in a week.
Exactly. Predictive maintenance tells you that a machine is going to break in 30 days. Prescriptive maintenance, which is what Daniel is essentially asking for, tells you exactly how to fix it, which tools to grab, and then shows you where to put your hands in real time. It prescribes the cure. It is the difference between a doctor saying, "You are sick," and a doctor saying, "Take these 3 pills in this specific order while standing on your left leg."
So, to answer the first part of the prompt, yes, this tech absolutely exists. But there is a huge gap between what is happening on a Boeing factory floor and what Daniel can do in our living room with his OnePlus phone or his old pair of smart glasses. Herman, let's break down the convergence. For Daniel to get that video game overlay on his CPU cooler, how do these two technologies actually talk to each other?
It is really a 3-part harmony. You have the eyes, which is the computer vision. You have the brain, which is the multimodal artificial intelligence. And then you have the hands, which is the augmented reality interface. If any one of those 3 is lagging or inaccurate, the whole experience falls apart and you end up snapping a piece of plastic off your motherboard.
Let's start with the eyes. Because for an artificial intelligence to give you an overlay, it has to know exactly what it is looking at in 3-dimensional space. It is not just identifying a picture of a fan. It has to understand the depth, the angle, and the orientation of that fan relative to the user's head.
Right. And that is where things like LiDAR and SLAM come in. SLAM stands for Simultaneous Localization and Mapping. It is the same tech that helps a robot vacuum cleaner navigate your house without eating your socks. It creates a point cloud of the environment. In 2026, the computer vision part has gotten incredibly fast. We're seeing models now, specifically things like Gaussian splatting and neural radiance fields or NIRFs, that can take a quick scan of a room or a piece of machinery and create a high-fidelity, three-dimensional reconstruction in seconds. We are seeing models now that can look at a circuit board and identify every single capacitor, resistor, and jumper pin in milliseconds just by the spatial geometry. It doesn't need to see the labels printed on the board, it recognizes the face of the hardware.
So the artificial intelligence sees the board. It has a three-dimensional map, but then it has to know what to do with it. This is where the large multimodal models come in. In the past, if you wanted an AR repair guide, you had to program a specific guide for a specific motherboard. If you had the ASUS version instead of the MSI version, the software was useless because the pins were 3 mm to the left.
That was the old way. That was the era of digital twins where you had a perfect, expensive virtual copy of a machine. But now, with multimodal AI, the system does not necessarily need a pre-rendered three-dimensional model of every single computer ever made. It can use its general knowledge of electronics, mechanical engineering, and physics to look at a part it has never seen before and reason its way through the repair. It is like hiring a master mechanic who has never seen your specific car, but understands how internal combustion engines work fundamentally.
That is the aha moment for me. It is the difference between a static manual and a dynamic expert. If Daniel is looking at a fan clip, the AI can see the tension in the metal. It can see the little notch where the clip is supposed to catch, and it can say, okay, based on the physics of this latch, you need to apply pressure at a 45-degree angle toward the center of the socket.
And then it draws an arrow. That is the augmented reality part. It anchors that arrow to the physical clip. So even if Daniel moves his head to get a better look, or if he bumps the server with his elbow, that arrow stays stuck to the clip. This is what we call spatial grounding. It is the absolute bridge between the digital instruction and the physical reality. In 2026, we are finally getting to the point where the jitter is gone. The digital object feels as solid as the physical one.
Now, why can't Daniel do this right now with his phone and a chat interface? He was saying he has to take a photo, send it, wait 4 seconds for a response, and then the AI says, look at the 5th pin on the 2nd row. By the time he reads that, he has forgotten which row was the 2nd row. That is still very clunky.
It is a bandwidth and latency issue mostly. To do what Daniel wants, real-time, low-latency overlays, you need a constant video feed being processed at 30 frames per second or higher. If you are doing that over the cloud, even with 5G, you have latency. Your hand moves, but the arrow stays where your hand was half a second ago. That is a recipe for a headache. If you are trying to do it on the device, you need a lot of local processing power. We are starting to see this change with things like the Apple Vision Pro 2 and the newer industrial headsets from companies like Magic Leap and Microsoft. They have dedicated silicon just for spatial processing.
Let's talk about the Vision Pro for a second. Apple has been pushing their visual intelligence features quite hard in the latest OS updates. If you are wearing a headset, it can identify objects in your field of view. But even there, we are still in the early stages of a truly interactive repair guide for consumers. Most of the apps are still just floating PDFs.
True, but look at what Microsoft is doing with Dynamics 365 guides on the HoloLens. This is already happening in heavy industry, and it is where Daniel's dream is currently a reality. Companies like Toyota and Boeing use this for training in complex assembly. A technician puts on a headset and they see a three-dimensional ghost of the part they are supposed to install floating over the actual machine. The AI tracks their hands. If they pick up a 10mm wrench when the manual calls for an 8mm, the AI highlights the wrench in their hand in red and points an arrow toward the correct one.
I remember reading about a case with ThyssenKrupp, the elevator company. Their technicians used to have to carry huge manuals or call a senior engineer on a radio for every weird edge case in an elevator shaft. Now, they use augmented reality to visualize the entire elevator shaft through the walls. They can see where the cables are routed, where the sensors are hidden, and the AI provides a step-by-step overlay for the specific error code the elevator is throwing.
And in 2026, that has been supercharged with generative AI. It is not just showing you a fixed diagram anymore. The AI can actually generate a custom repair path on the fly. If the technician finds a part that is rusted or bent in a way the manual didn't anticipate, the AI can look at that specific damage, simulate the physics, and suggest a workaround. It might say, the standard bracket won't fit because of this corrosion, so use the secondary mounting point at this specific torque.
That is the prescriptive part you mentioned earlier. But here is the thing that worries me, Herman, and I think this is a huge hurdle for this field as it moves from the factory to the home. What happens when the AI hallucinations meet the physical world? In a text chat, if ChatGPT tells me that George Washington invented the internet, it is annoying. In a complex repair, if the AI tells me to cut the green wire, but it is actually a high-voltage power line, or if it tells me to apply 20 pounds of pressure to a fragile silicon die, it is catastrophic.
You've hit on the biggest bottleneck in the industry right now. We call it the deterministic gap. Most generative AI models are probabilistic. They are guessing the next most likely word or pixel based on a massive data set. But industrial repair needs to be deterministic. It has to be right 100% of the time. You cannot hallucinate a torque spec.
So, how are they fixing that? Because you can't just tell an AI, don't lie. It doesn't know it is lying.
They are moving toward what we call explainable AI, or XAI. Instead of the AI just saying, do this, it has to cite the specific data point, the specific page of the service manual, or the specific engineering constraint it is using to make that recommendation. And we are seeing the rise of small language models, SLMIs, that are trained exclusively on technical data. They don't know how to write poetry. They don't know who won the Oscar for Best Picture in 1994, but they know every single bolt pattern for a 2025 jet engine. By narrowing the focus, you drastically reduce the chance of a hallucination.
That makes a lot of sense. You don't want your repair assistant to have a creative side. You want it to be a boring, hyper-accurate expert that refuses to guess. If it doesn't know, it should say, I don't know, call a human.
Exactly. And there is also a shift toward edge AI. To avoid that latency Daniel was talking about, companies are building specialized chips, neural processing units, that can run these models locally on the headset itself. That way, the AI can react to your hand movements in microseconds. If it sees your screwdriver slipping, it can flash a warning before you even realize you have lost your grip.
Let's go back to Daniel's specific scenario. He is working on a home server. He is not a professional technician at Boeing. He doesn't have a $5,000 HoloLens. When does this become a consumer reality? When can I put on a pair of glasses that look like my normal frames and have them show me how to fix my leaky sink or my broken toaster?
We are closer than you think, but we are in that awkward teenage phase of the hardware. Apple is reportedly working on a project code named N50, which are AI-powered smart glasses that look much more like traditional eyewear than the Vision Pro. Meta is doing the same with their Ray-Ban collaboration, which has been a huge hit. Right now, those Ray-Bans can tell you what you are looking at through the speakers. They can say, that is a leaky U-bend under your sink, but they don't have a full three-dimensional display yet.
Right. They can talk to you, but they aren't projecting arrows onto the pipe yet. You are still working with audio cues, which is better than nothing, but it is not the spatial experience Daniel is asking for.
Exactly. That is the next big leap, the transparent waveguide display. Once we get a display that is transparent, light enough to wear all day, and has a wide enough field of view, combined with the multimodal brains we already have, the YouTube tutorial era is over. Think about it, Korn. For 15 years, if you wanted to fix something, you watched a video of someone else's hands fixing their sink. You had to translate their movements to your movements. In the very near future, you will just see the instructions on your own sink. The how-to is overlaid on the what is.
It really changes the concept of expertise, doesn't it? If the knowledge is on demand and spatially anchored, do you actually need to know how to fix a computer, or do you just need to be good at following directions? Does the skill shift from knowing the information to having the manual dexterity to execute the AI's instructions?
It is a profound shift. It is the democratization of skilled labor. It lowers the barrier to entry for DIY projects, which is great for sustainability and the right to repair movement. But I would argue it actually makes human judgment more important, not less. The AI can show you where the screw goes, but it can't feel if the screw is about to strip the threads. It can't smell if a component is burning in a way that isn't visually obvious. That tactile feedback and sensory integration are still uniquely human.
That is a great point. The AI provides the what and the where, but the human provides the how it feels. Although, knowing you, Herman, you are going to tell me that someone is working on feeling too.
People are working on that. There are haptic feedback gloves and even ultrasonic haptics that can create the sensation of touch in midair. Imagine the AI not only showing you the bolt, but giving you a little vibration on your fingertip when you have reached the correct tightness. We are seeing these integrated into the augmented workforce in high-end manufacturing already.
The augmented workforce. I love that term. It is not about robots replacing people. It is about making people much more capable. If a junior technician with a headset can do the work of a senior engineer with 20 years of experience because the senior engineer is essentially an AI whispering in their ear, that solves a lot of the labor shortages we are seeing in the trades.
It does. But it also creates a new kind of digital divide, and this is something we need to be careful about. If you don't have access to the latest Repair Brain subscription, or if your glasses are an older model that doesn't support the latest spatial mapping, you are at a massive disadvantage. And then there is the question of proprietary data. Will manufacturers like Apple or John Deere or Tesla give these AI models access to their proprietary repair data? Or will they lock it down so only their official expensive headsets can see the repair guides?
Oh, that is a huge one. That is the spatial right to repair. Imagine your glasses saying, I recognize this is a proprietary transmission, but the manufacturer has blocked the repair overlay. Please contact an authorized dealer to unlock this visual data for $99.
That is a very real possibility. We are already seeing software locks on physical hardware where a part won't work unless it is digitally paired to the motherboard. Adding a spatial lock to the repair information would be the next logical and depressing step for some of these companies. We might see a world of open-source repair brains, where the community creates their own spatial maps of hardware to bypass these corporate walls.
So, to recap for Daniel, the field is spatial computing or augmented maintenance. The tech is converging through the combination of computer vision, specifically SLAM, and LiDAR, multimodal AI that can reason through mechanical problems, and world-locked AR overlays. It is currently very mature in the industrial space. Think aerospace, elevators, and automotive assembly. But for us consumers, we are still waiting for the hardware to become as light as a pair of wayfarers.
Exactly. The brain is ready. ChatGPT and Gemini and Claude can already reason through a repair if you give them enough photos. They can tell you that a capacitor is bulging or that a cable is plugged into the wrong header. But we are still in that awkward phase where we have to hold a phone in one hand while trying to work with the other. It is like trying to play the piano while holding a sheet of music in your teeth.
Which is exactly why Daniel was so frustrated. You need both hands for a CPU cooler. You can't be a cameraman and a technician at the same time.
Precisely. The moment we get hands-free spatial AI that is affordable, the game changes. And I think we are maybe 18 to 24 months away from that being a semi-affordable consumer reality. We are talking about the end of the year 2027 or early 2028 for the iPhone moment of AR glasses.
I'm curious about the data side of this, Herman. For these AIs to be accurate, they need to be trained on massive amounts of three-dimensional data. Where is that coming from? Are they just scraping every YouTube repair video and trying to turn it into a three-dimensional model?
That is part of it. There are actually algorithms now that can take a two-dimensional video from 2010 and reconstruct the three-dimensional space and the objects within it. But the real gold mine is synthetic data. Companies take a three-dimensional CAD model, computer-aided design of a machine, and they run millions of simulations in a virtual environment. They show the AI what the machine looks like from every possible angle, in every possible lighting condition, and even what it looks like when it is broken, dirty, or covered in dust.
So the AI has seen a broken version of Daniel's server millions of times in a virtual world before it ever sees the real one on his desk.
Right. It is called sim-to-real transfer. You train the model in a simulation where you can control everything, and then you transfer that knowledge to the real world. It is how they train self-driving cars to handle snow and rain without actually crashing thousands of cars. And now, it is how they are training your future repair assistant to recognize a stripped screw head from a mile away.
It is fascinating how all these separate threads, gaming, robotics, linguistics, and optics, are all weaving together into this one tool. It feels like the ultimate utility. It is the end of the RTFM era. Read the manual. Because the manual is no longer a separate thing you have to consult. The manual is now part of the environment.
It really is. The environment becomes semantic. Every object in your house will eventually have a digital layer of information attached to it that your glasses can read. Your toaster will tell you how to clean the crumb tray. Your thermostat will show you where the batteries go. Your car will show you how to check the oil. It turns the entire world into a giant, interactive museum exhibit.
I just hope the manual doesn't have ads, Herman. Imagine trying to fix a brake line on your car and having to watch a 30-second unskippable ad for a local pizza place before the AI shows you which bolt to turn.
Don't give them any ideas, Corn. Your repair will resume after this message from our sponsors. That is the true dystopia. Or imagine the AI saying, I see you are using a third-party screwdriver. For the best experience, please purchase the official Apple iDriver.
Honestly, though, think about the safety implications. This is the part that really excites me. If you are a DI, you're working on something dangerous, like a high-voltage electrical panel or a car's suspension under tension, having an AI that can say, stop, that capacitor is still holding a lethal charge, or that spring is under 3,000 pounds of pressure, do not remove that bolt until you have the compressor in place. That could save lives.
It absolutely could. We are seeing safety AI being integrated into construction sites already. There are cameras that can spot if someone isn't wearing their hard hat or if they are standing too close to a trench that might collapse. Bringing that into the home for DIY repairs is a massive win for public safety. It turns a weekend warrior into a safe professional.
I can even see a world where your home insurance premium actually goes down if you use an AI-certified repair guide for your plumbing or electrical work. Because the insurance company knows the job was done correctly according to the building codes, rather than just some guy winging it with a wrench and some duct tape.
That is a very plausible 2030 scenario. Proof of correct repair via a spatial recording. Your glasses record the whole process, anonymized hopefully, and the AI verifies that every step was followed, every bolt was torqued to spec, and no leaks were detected. It is a permanent, verifiable record of the work. It would make buying a used car or a used house much less of a gamble.
It is a lot to think about. We went from Daniel struggling with a tiny metal clip on a fan to the total transformation of human labor, insurance, and the very nature of expertise. But that is why we love these prompts. They seem small, but they pull on a thread that is connected to the entire future of our species.
It is all connected, Corn. From the 84 Mac Logic board I was working on this morning to the spatial headsets that will be on everyone's faces by the end of the decade. We are moving from a world where we have to learn how to use tools to a world where the tools help us learn how to use them.
Well, on that note, I think we have given Daniel a lot to chew on. Daniel, hang in there with those fan clips. The future is coming, and soon you will have a digital guardian angel showing you exactly where to push. If you are listening and you have had your own, I wish an AI would just show me how to do this moment, whether it is cooking a complex meal or rebuilding a transmission, we want to hear about it.
Definitely. And hey, if you have been enjoying our deep dives into these weird prompts, please take a second to leave us a review on your favorite podcast app. Whether it is Spotify, Apple Podcasts, or the newer spatial audio platforms, those ratings really help more people find the show and join the conversation.
Yeah, it genuinely makes a huge difference for us. We are an independent show, and your word of mouth is our only marketing. You can find all our past episodes, all 756 of them, at myweirdprompts.com. We have a full archive there, searchable by topic, and if you have a prompt of your own that is keeping you up at night, there is a contact form right on the site.
Or you can just email us directly at show@myweirdprompts.com. We read every single one, even if we can't get to all of them on the air. We love hearing about the weird technical corners you guys find yourselves in.
This has been My Weird Prompts. Thanks for hanging out with us in Jerusalem. I am Corn.
And I am Herman Poppleberry. We will catch you in the next one.
Goodbye, everyone.
Bye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.